All right, Algebra 2, guys, we are starting a new chapter. All right, we are in chapter 11, and I want to start first by saying chapter 11 is quite different than probably all other chapters in this textbook. All right, so we are learning about statistics, basically. All right, so we're going to be doing a lot of stuff with probability and the odds of something occurring. And so that can be a little bit different for some students. And a lot of times, this is a chapter where intricate phrasing and the words that you read in a problem are vital. And that means that you have to pay close attention to all of the phrasing in these problems. Okay, so I want to make sure that you understand that right from the get-go and make sure that you guys are giving it your all. All right, it's important because I know as we move and get closer to the end of the textbook, that is you guys getting closer to checking out. And you can't afford to do that. You have to ask questions. You have to pay attention to these note videos. You have to focus, focus, focus. All right, so here we go. First section in chapter 11, all about permutations and combinations. All right, words that you may have never ever heard before. Okay, so a permutation, you're going to basically be given on this whole page here all of your necessary notes, all the necessary stuff to copy down. A permutation, one of the ways to think of this is when the order of a given situation matters, then that would be under the category of a permutation. When the order of a given situation matters, okay? So in other words, if you are reading a problem and then they start to give you very specific or really like detailed instructions, like you can do this, but you can't do this, then the order of that matters. And when the order matters, that's going to direct you towards the fact that you need to use what's called a permutation, okay? And when you're doing a permutation, you will be focusing on this equation right here, okay? In focusing on this equation right here, you're going to notice that you have these exclamation points. And it's not like we're in English here. It's not like we're doing something that requires like a literary background, because that exclamation point is actually this guy right here. That is called a factorial, okay? And in math, when you see a number and then an exclamation point, that's actually you saying like factorial of, or factorial of 6, which is the example you get right here. And basically a factorial is when you take the given number, so for this example, factorial of 6, and you multiply this number by everything underneath it all the way down to 1. So that is one of the necessary concepts in section 1, is you're going to see these numbers and then an exclamation point, which really means factorial of, and that is going to be you taking that number and then multiplying it by every other number underneath it. Okay, now there is a trick. There's a calculator trick for some of these problems, and I'll be teaching you that as we get a little bit further into the example problems, and that's going to help a lot. All right, that's going to save you time as far as doing calculations. It's also going to save you a lot of time in the fact that you won't actually have to put in all of those numbers right there. You're just going to need to find the factorial category within the calculator, which is really easy once I teach that to you. Okay, so we've talked about permutations. Let's talk about combinations. All right, a combination is when they give you a situation and order does not matter. So for a combination, that's going to be them giving you a situation, giving you a word problem. And in that word problem, the order doesn't matter. They're just going to say, here are all of the necessary pieces numerically that you have to understand. Let's say you're given 10 people and you're just trying to pick 2 people from that group of 10. Well, order doesn't matter in that situation because you can pull any 2 people from that entire group of 10. So that would be a combination. But let's say you were to switch this up and say you got a group of 10 people, you're trying to pick 2 people, but you can never pick the same person twice. Well, now I just put a stipulation on it. I put some requirements that started to hinder the number of possible outcomes. Now I just changed it from being a combination to now being, as we discussed earlier, a permutation. Okay, so that is when you start putting requirements on the given situation that you have there. Okay, and then the last piece, actually the easiest piece, is called the fundamental counting principle. All right, and this is basically when they're going to say, hey, here's all these different options. All right, so an example of this would be like, let's say you're trying to pick out a full 3-course meal at dinner, and you're going to have the first meal be a salad, but there's 3 different salad choices. Then the second part of the meal is the main course, but there's 5 different options for the main course. And then the third part of the meal is your dessert. And in that situation, let's say you had 3 possible desserts. So you had 3 salads, 5 main courses, and 3 desserts. The fundamental counting principle just says, take your options and multiply them together. So 3 times 5 times 3. That's all you would have to do to calculate that type of a problem for the fundamental counting principle. All right. Now, where the fundamental counting principle can get to become a little bit big is when you are dealing with choosing letters or choosing digits. And the reason why this gets to be a little bit cumbersome is because you got to remember, all right, if we have 26 letters in the alphabet, and then let's say you're picking like uppercase and lowercase, well, now you're looking at 26 times 2, and then that's just going to become a lot bigger because you got 26, depending on how many letter choices. Maybe there's 3 letter choices. Well, then that could be 26 for uppercase, another 26 for lowercase, put them together, 52. Well, now you got 52, 52, 52, and you're going to see an example problem very similar to that. Okay, so enough talking. Let's get into the example problems here. All right, so the first one is an example dealing with the fundamental counting principle. All right, so we have a make your own adventure story, and you have all of the possible choices that you get. All right, so you have 6 starting points. So we're going to write 6. Then you have 4 plot choices. So then we're going to write 4. Then you have 5 possible endings to that. So we're going to write 5. So what we are now gathering here is all of the necessary pieces to the whole adventure story. You have 6, you have 4, you have 5. And when you put all of these guys together, it's just the fundamental counting principle. So 6 times 4 times 5, and that works out to be 120 different adventures that you could choose from based upon which choices you make with starting, plot, and ending. So that is a fundamental counting principle example right there. Pretty straightforward. It gave you the necessary pieces really easily. Example problem number 2 is also a fundamental counting principle, but this one, this is what I'm talking about when I say they enhance this. There's a lot more going on in this. So you have a password, all right? And in the password, there are 4 letters, and then you have 1 digit. But this is a key piece. You have uppercase letters and you have lowercase letters. So in this example, that means that you have 26 uppercase and 26 lowercase. And as they say here, those are considered different. So that means that you have 26 and 26 actually making a total of 52 letter possibilities. And if there's 4 letters, then you're actually looking at 52 times 52 times 52, and yes, times another 52. 4 possible letters. They didn't tell you anything about letters not being allowed, so all 52 possibilities are there, followed by 1 digit. Well, 1 digit means 0 through 9. And 0 through 9 actually gives you 10 different digit possibilities in picking the 1 digit number. So now you're looking at a very big number here where the password is 4 possible letters, uppercase and lowercase are different, then 1 digit, 0 through 9. Work out all the math there, plug that into the calculator, and this is going to create a much, much bigger number than our first one. I believe we're looking at 73,116,160. There is a lot of different password combinations there for just 4 letters, 1 digit, and you notice we're not even using special characters. So that's something to think about. When you're actually creating passwords nowadays, there are so many millions, if not billions, of different options depending on how long you make it, special characters, signs, all the different stuff that goes in there. So that covers 2 examples from the fundamental counting principle. Now let's do our third example. So this one right here, I'm going to teach you one of the calculator tricks. All right, so let's read this. How many ways can a 2-digit number be formed by using only the digits 5 through 9? So that means 5, 6, 7, 8, 9. There's 5 total digits that we're picking from there. Again, only from 5 through 9. So 5, 6, 7, 8, 9. Now here I've highlighted the important piece to try and teach you guys what you have to really be looking for in these problems. It says each digit being used only once. Now that is them putting a restriction on the problem. And when they put a restriction on the problem, that is one way of determining that order matters. Order matters. And if order matters, we're looking at a permutation. And real quick, the permutation, it's going to be n permutation r. So let's write that. We have n permutation r. N is always the bigger number, and r is always the smaller number. We need to figure out what is the bigger number, what is the smaller number. Well, let's go back to what we gathered from the problem. There's actually 5 total digits, and you are trying to create a 2-digit number. So that means we are creating 5 permutation 2. Those are the only values we're able to pull out of this. You're not counting like 5 is a number and 6 and 7 and 8. No. You are gathering what's the total quantity of digits I can use. There's only 5 total digits. You're picking 2 of those, and as the problem states, each digit is only used once. So order matters. Now here comes the calculator trick. All right, turn the calculator on, then push the math button, that's in the far left column, and then push the right arrow all the way over to where it says PRB. PRB stands for probability. Then go down to the number 2 where it should say N capital P lowercase r. Now, I will admit I kind of skipped one little step here. The one little step is that you actually first in the calculator have to punch in the number 5. All right, so you got to go back to the home screen. My apologies. Punch in the number 5 because that has to come first. Then go back into the calculator part, hit math, move over to probability, then go down to number 2, NPR, push that, then push the number 2. So when you plug this into the calculator, it should look like 5. Sorry. Should look like 5. Then you're going to have a little space, NPR. Then you should have the number 2. Then hit enter. And the calculator does the permutation for you. And the answer you should get for this one is 20. So that means there are 20 different ways to pick from the digits 5 through 9, but only using digits once. So that's going to really change how many options you can have here. All right, so let's take a look at example problem number 4. Read this one here. A swim team has 8 swimmers. 2 swimmers are going to be selected. How many ways can the swimmers be selected? Notice no restrictions here, and there's no someone saying, oh, once a swimmer's picked, they can't be picked twice. The order of it isn't changing. So in this situation, order does not matter. They're not putting any restrictions on it for us. They're saying, here's 8 swimmers. Just pick 2 of them. Pick any 2. Doesn't matter. So no restrictions means this one goes into this category. It's a combination. And if you didn't see it when you went into the probability part of the calculator, there is the exact same thing right there when we go into math and probability. So we are setting this one up with a combination and then R, okay? And then we are, again, N is the bigger value, R is the smaller value. So this is going to be 8 combination 2. Now, when you plug this into the calculator, don't forget, push the number 8, then go into math, probability, combination, then push the number 2. So when you plug this into the calculator, it should look like 8, then a little space, N combo R, then 2. And when you plug that into the calculator, you are going to get 28 as our quantity of ways to pick from 8 swimmers, just picking 2 of those. All right, guys, that's it. That's section 1. And one more calculator trick I want to show you guys. When you hit the math button, go back over to probability, take a look down at number 4. There's the exclamation point. That's your factorial button. So whenever they give you a problem, just like this right here, which you may have a few real easy problems where they're going to just say number factorial, don't do all those numbers. Don't do all those steps. Just push the number, then go math, probability, go down to number 4 and get that factorial exclamation point there. Then hit enter, and then everything's going to be done and all good. All right. So I think that covers it right there. And that's it. That's the page you're looking at. All right. And I was requested throwing another random question for you guys. So you're watching all the way to the end of the video. So if you can go ahead and add to your notes. Let's see. Mr. A loves The Office. Let's go specific to Dwight. Find your favorite quote from Dwight K. Schrute. There you go. All right. I will see you guys in the next video.